Well, hi everybody. In this screencast, we take a look at continuity. Continuity is that thing that's really easy to see from an intellectual standpoint. That's continuous. That's continuous. That's continuous. But that's not because it's got a hole in the middle. But of course, when you're trying to describe that to somebody who is mathematical, you want to use a rigorous definition, and so here is a rigorous definition. A function y equals f of x is continuous at an interior point C of its domain if the limit as x approaches C of f of x is f of c, which means that the limit has to exist, the function value has to exist, and they match. The limit has to exist, the function value has to exist, and they have to match. The limit and the function value have to match. So we could talk about the kinds of discontinuities we've talked about. We have already discussed this semester a jump discontinuity. In a jump discontinuity, this is C, there is no limit as x approaches C, so it fails the definition. We could talk about infinite discontinuities. Infinite discontinuities, well, we're not continuous at C because f of c isn't the limit. Even if f of c could be the limit is infinity. F of c can't be infinity. Infinity is not a number. So if a function is going to be continuous, it is going to satisfy this definition. That's a really nice thing to tuck away. A function is continuous. If you're making index cards with definitions on them, this is one of the definitions on an index card. There is a limit, there is a function value, and they match. Now, the upside for us, if I have two functions and they're both continuous at a particular value of c, then so are their sum, their difference, their product, their quotient if g of c is not 0, any vertical stretch of f, f to any power, any root of f, all of those are also continuous once you have a couple of continuous functions. Now that's great because that implies that every polynomial is continuous. And that's great because there are properties of continuous functions that are instantly given to polynomials. Likewise, the quotient of two polynomials is continuous if the denominator is not 0. And you can compose functions. I mean, there are all sorts of ways to generate continuous functions from continuous functions. That's a nice thing to have handy. But not everything is a polynomial. So consider the following, Bill Nye the Science Guy. Let f of x be 3x plus the sine of 3x over 3x. Let's create what we will call a continuous extension to x equals 0. And the reason we have to create a continuous extension is because at x equals 0, f of 0 does not exist. And if f of 0 does not exist, then the function f is not continuous at x equals 0, is not continuous. But if you were to look at a graph, you would see a hole at x equals 0. And our job is to plug up the hole. That's what we're going to do. We're going to plug up the hole. So what I'd like to do is I'd like to find the limit as x approaches 0 of this thing. And I think we can do that because I'm pretty good with fractions. And I know that if I have a singular denominator, I can break this sucker up. And then all I have to ask myself is, self, what is this limit as x approaches 0? And I think you're going to figure that out fairly quickly. And then what is this limit as x approaches 0? And if you were paying attention in our last lesson, you know that that is also 1. And so I get that there's a hole in the function at 0, 2. 0, 2. So if that's the case, then I define some function g of x, and g of x is going to be f of x except at 0. Because f is fine except at 0. But at 0, I want to plug up the hole. And the way we plug up the hole is by saying that's where the hole is. And that creates a continuous extension. This g function is exactly the same as the f function, but we plug up the hole. Okay? Okay. So time now for a who cares. Who gives a rip about continuous functions? Well, these people do. This is the Intermediate Value Theorem. And the Intermediate Value Theorem says if f is a continuous function on AB, and if k is any value between f of a and f of b, then k is f of c for some c on AB. What the heck? Well, picture time. Here's A, here's B. Take some continuous function. Whee! There it is. It's a continuous function. Here's f of A, and this is roughly f of b. You pick any value between f of a and f of b, and that corresponds to some x value between a and b. At least one. The side note on this theorem is it's an existence theorem. It doesn't tell us where C is. It doesn't tell us where the roots are. It doesn't tell us where C is. It doesn't tell us how many C's there are. It's like if I go to, is there a serial killer in my neighborhood, and I type in my zip code, and it says yes. Doesn't tell me where they are, doesn't tell me how many there are. It just says there is at least one. So how do we use this? I want to show, that's a terrible show, I want to show that f of x equals x cubed minus 6x squared plus 4x plus 5 has at least 1 0 on, whoa, sorry about that, folks, on negative 2 to 6. So I'd like to use the intermediate value theorem, and so I'd like to guarantee that this is a continuous function, and luckily enough for us, polynomials are continuous, so the intermediate value theorem applies. Well, that's helpful. Now, consider f of negative 2. F of negative 2, so I sub in negative 2, that's negative 8, minus 24. I don't know what that is because my arithmetic is so bad, but I'm pretty sure it's negative. And then f of 6, I'm really bad with arithmetic. This is 216 minus 216 plus 24. I don't even know what that is, but whatever it is, it's positive. So here's the thing. I have a continuous function, and at negative 2 it's negative, and at 6 it's positive. Does there have to be a root? Sure there does, because it's a continuous function. And you could say, well, I'm not going to cross that, but if I'm going to get up to here, I kind of don't have another way to go. I've got to cross. There's got to be a 0. And so as soon as I find some place where my function is negative and some place where my function is positive, by the intermediate value theorem, f of x has a 0 on that interval. You might notice that when you have a graphing calculator and you ask it to find a 0, it asks you to bring your itsy bitsy spider to the left of the root and then to the right of the root. Well, what are you doing? You're finding some place where the function is positive and some place where the function is negative, and then there's an algorithm inside the calculator that figures out, okay, there has to be a 0 here, so let's go find it. Okay? That's who cares. That's a very important theorem. Without continuity, we don't have the intermediate value theorem. And the intermediate value theorem matters in the stuff we're going to do later in the semester. Okay, so there it is. That's your look at continuity. I'll see you soon.